What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. Welcome to part 4 of our tutorial series, Scientific and Numeric Computing in Python. So, guys, if you have been following along, right, you know that in the previous video, what we looked at and what we explored was some ways in which we can use the NumPy package and the related or associated functions that's given to us with the package in order to go about creating ND arrays. So we looked at quite a few ways in which we can create NumPy arrays using NumPy's functions that are available to us for use. Now, in this video, part 4 of our tutorial series, we will continue exploring the NumPy package and we will basically be introduced to, more methods and features and concepts that NumPy allows us to do. So, let's get to it. I will create a cell and I will import NumPy again. So each time I run my code, I'm not running all the lines we previously coded. So let's take things one step at a time. Firstly, I'd like to proceed and create a 1D array. Okay, to do that, I'm going to use the arange function, and by now you guys should be very on par with what the arange function does, as well as the names of the parameters themselves, because as you know, as we've been coming along in the tutorial series, we've been discussing the function itself as well as typing the full names of the parameters. Okay, and in doing so, I mentioned this before, and it's a practice that I always try to enforce for myself as well whenever I am coding. I try my best to always type out the names of the important parameters and their arguments. You'll find that in doing so, you give yourself the edge of understanding the logic behind every function that you encounter. So start, stop, and step. At this point, though, you guys, it's not compulsory for you to keep coding the names of the parameters, especially of a function that we've encountered so frequently, but the preference is yours. At the end of the day, you need your Python script to look professional, so that at any point in your life, if you decide to look back or reference this Python script, it needs to be in tip-top shape. So I created a 1D array. As you can tell, there will be 1000 elements in this array from 0 to 999. So to give you a bit of insight, let's print array 1D. And as you guys can see, we have a NumPy array there. So I would like to talk now about a concept, right? A concept, a technique that we are going to talk about for the first time. It is known as reshaping an array. Okay, it is a very, very interesting procedure. It's a transformational process that can be applied to an array. Okay, especially NumPy arrays. Now, reshaping an array is something that is often encountered and utilized or done, especially in machine learning. Okay, certain situations and certain problems require you to reshape your target vector, or your features matrix, or your input data, and so on. Now, the general aim of reshaping an array is to really take the shape that we have and convert it or transform it into another shape. Now, the key thing that you need to understand is that the array before reshaping and the array after reshaping need to have the exact same amount of elements. Okay, and guys, I should mention that reshaping an array requires you to have and utilize some form of logic, right? What I mean by that is, if I have, you know, if I have an array that contains 9 elements, I cannot transform or reshape that array into an array that has a shape of 2 by 2, right? What I mean is that if I have an array that's 9 by 1, 9 rows, 1 column, I cannot take that array okay, and make it a 2 by 2. I cannot do that, okay? A 9 by 1 array tells me that there's 9 elements. So I will have the ability to take that 9 by 1 array and definitely make it into a 3 by 3. That's a square, an array in the form of a square representation. So from a 9 by 1, so I'll give you a simple example. This is us just discussing logic, right? So I'll give you an example. I have an array, 9 elements, 9 by 1. So let's say my array contains 1 2 3 4 5 6 7 8 and 9. That's my array. Now I can reshape this array. Instead of having it in the form of 9 by 1, what I can do is I can have it in this representation. This is in the form, I'm missing a comma. Okay, so this is in the form of two different shapes. I will give you more insight into this before we actually proceed to look at the reshape method in NumPy. So NumPy array, this is just us taking that standard Python array and converting it into a NumPy array. So okay, now I'm going to run that and I'm checking r1.shape. As you guys can see, that's a 9 by 1 as we've had. r2.shape, that's a, oh, my apologies guys, I missed a square brackets. So basically what I'm doing is I'm taking a single dimension array in the form of one column and I'm transforming it into a two-dimensional array that has the ability to give us more rows and more columns. The first array we see, as you can see, we have it here. The shape is 9 by 1, telling us that there's only one column. Now you're going to observe, I'm going to make an adjustment to array 2, and you are going to see for yourself how the representation or the shape of the array changes. So I'll do this from scratch again with you. This time we will be using the proper way. So you guys know, right? This is also something I should mention. What we are about to do now is going to give you a very high level of insight into the use of square brackets and how they change the dimensions that your array has. Okay, so I need one pair of square brackets because that is going to be the array itself. Okay, that's my array enclosure. Now, within this array enclosure, I have sub arrays or sub lists. You can call it what you like, right? As long as you understand this. I have sub lists or sub arrays that are going to give rise to dimensions. So I'm reshaping that 9 by 1 into a 3 by 3. And this is how it will be done. Okay, I'm going to do 1 2 3, a comma. Notice guys, notice 3 elements are enclosed by their own pair of square brackets, and that gives rise to a dimension. This itself, that one pair of square brackets and all elements contained within, is row 1 of the array. And as you can tell, because of the fact that this is enclosed in one pair of square brackets giving rise to row 1, this itself has 3 columns. Okay, I hope this is making sense to you guys. Now I'm adding row 2. In row 2, column 1, I'm placing 4. In column 2, 5. In column 3, 6. I'm adding one more row. In row 3, I'm adding the values 7, 8, and 9. Okay guys, I hope this is making sense to you. And now as you will observe, I will print the shape this time directly from here because I mean we are done coding the little bit of logic about reshaping. So this is the first example, right? We will consider this the first example. This is my own example. I'd like to give you another example from a source which I referenced. So I'm running this again. Let's comment this out for now. Okay, that's array 1, array 2. Brilliant. Now I would like to show you guys r1.shape, r2.shape. And I would like you guys to notice, observe. We had a 9 by 1. I have successfully converted that into a 3 by 3. Okay? The question lies in, does my original array and the new array, the one which I'd like to reshape it into, do they have the same number of elements? The answer is yes. And that is how reshaping works. That's like one of the most important rules you guys need to understand and pay attention to when you are attempting to reshape an array. Okay, I'll give you another example. So this time we will utilize our a range. We can make this our first example, guys. So here, example 2, I'll remove that. So you guys saw what array 1D looks like. I'll create another cell here. So array 1D was that one with 1000 elements in it. Now let's ask ourselves, an array, this is a single array. What I mean by that is that it's just having 1000 rows in one column. An array that is 1000 rows by one column, logically speaking, it is having a very similar representation of 1000 columns and one row. Okay, what I'm saying is that the array that we are working with here, the a range array having from 0 to 999, 0 1 2 3 4 5 6 7 and so on. This is the representation of that array. To prove it, we can do an array 1d dot shape, and you know for a fact that the tuple we see here given to us by the shape method is rows by columns, telling us that we have 1000 rows and it's all in one column. Okay, to help you guys understand the logic as well, you guys must always picture an array equivalent to a table. I'm sure you guys work with spreadsheets or any table that is having rows and columns. Our ND array in Python, our NumPy array, the logic is sort of very similar to the spreadsheet table. Okay, it's having rows, it's having columns. Now, as I'm saying, this 1000 rows by one column, there's it here, but it's there's not much different, logically speaking, in saying I have 1000 columns and one row. So if we have to take this array, 1000 rows and one column, and make it 1000 columns and one row, it will basically be having this 6 7 and then there. It's the same thing, guys. It's really just taking that array and kind of turning it sideways. Okay, this is just to help you understand that representation, how columns and rows affect a an array. So if we logic it out now, you'll see this is having 1000 columns. Why? Because each number here is in a column of its own. The comma is basically like the delimiter, okay, for our array. In NumPy, as you can tell, it's the space itself. So that is interesting. Anyway, I hope you guys I hope that makes sense to you guys. I hope you understand that. Anyway, coming back to our little example, we have an array, 1000 elements, right? Can I reshape that array to be 100 rows by 100 columns? The answer to that is, I'll give you guys like 2 seconds to either think yes or no, and I'm going to say the answer, right? So the question I asked was, if I have an array with 1000 elements, can I reshape that array to be 100 by 100? That is 100 rows by 100 columns. Now if you do the maths, right, 100 rows by 100 columns is giving us 10,000 elements, and I said I have 1000 elements. So the answer is no, I cannot. But if I have 1000 elements, Okay, can I take that array and reshape it into a three-dimensional array that is having 10 by 10 by 10? The answer is yes, because 10 times 10 times 10 is 1000, and I have 1000 elements. So let's multiply this, and there we have it. It is 1000. Okay, now I'm going to give you guys another example. So let us take this A range array we have, which is R1D. I am taking R1D. I know for a fact I am making it into a three-dimensional array. Okay, and you guys are going to see, the more you work with arrays of different dimensions, you will see how square brackets are arranged, how rows and columns get affected, and so on. It is interesting, guys. So array 3D is going to basically be array 1D that is reshaped. So r1d dot reshape, and I'm passing in shape of a tuple in the form of a tuple. It's going to have 10 by 10 by 10. Those are our dimensions. Okay, so now I am going to go ahead and I'm going to print array 3D, and you guys are going to see, right? All I did was pass the reshape, the new shape of the array I wanted to the reshape function, right? And NumPy is going to automatically add the square brackets and the formatting to the array itself, and you guys are going to see what NumPy does. The question is now, what we are going to attempt to find out is, how exactly does NumPy take a 1D array and transform it or convert it or reshape it into a 3D array? Okay, so I'm going to hit enter. First, I will comment this out because I just want to observe the 3D array. So I'm hitting enter. And have a look at this, guys. The output is quite a bit because we are working with an array that has 1000 elements. You guys, this is just an example. You can create your own array with X number of elements and play around with it, okay? Reshape it according to your needs or your, testing purposes. So, as you can see, right, I've mentioned this before, an array that is three-dimensional, you'll be able to tell based on the number of square brackets in the start and at the end. So in a 3D array, just to give you guys a bit of insight, right? The first square bracket we see here is the array itself, okay? Whether you have a 1D, 2D, 3D, or, a 10D or 100D array, okay, the first square bracket is necessary, the first pair, because that itself denotes the entire array. Okay, the second array you see here, okay, the second array you see, or the square brackets rather, yes, the second square brackets is the rows, the number of rows, and the third you see is the number of columns. That's basically what it's saying, right? So taking that logic, an array that's 10 by 10 by 10 tells us that basically within this array we have 10 collections of sub arrays, and within those 10 collections we have 10 rows each and 10 columns each. So I hope that makes sense to you. Okay, and yeah, you guys can check the shape of this array and play around with the reshape method. So just continuously or constantly play around with the shape and reshape. It is very interesting. Okay, well, another thing I'd like to mention to you guys is another example, just for clarification and explanation purposes, in case you did not really catch on something the first time. I'll give you another example. This time we'll scale it right down, right? So I'm thinking maybe let's do a small array. So let's create another array. Array 1D is equals to, let's do a numpy dot array. We'll manually create this array. we'll work with maybe a, let's see, 6, 7, 8, 9. I can make that a 3 by 3, or if I take 10, I can make that a 2 by 5. Yeah, let's work with this then. So we are taking 10 elements. As you can see, I am printing r1d.shape. I have a 10 by 1. Now taking that 10 by 1 array, I have the ability to reshape it, okay, transform the shape of it. What can I make it into? But can I make a 10 by 1 array into an array that is, 2 by 5? Is that possible? The answer is yes, I can, because an array that has 2 rows and 5 elements, in each column, that's why logically in each row it will be having 2 by 5, which is 2 times 5, that's 10 elements. I can take a 10 by 1 array and I can transform it into a 5 by 2, right? 5 rows, 2 columns. I can make it a 2 row, 5 columns. That's why I'm saying, guys, this is really very interesting. Like, I could go on and on just giving you guys examples, and it is really fun. So let's go ahead and experiment with this now. So I know for a fact that I want to transform this array into a 2D array. I'm doing numpy dot r1d dot reshape. The shape I am aiming for is a 2 by 5, and I'm printing r2d dot shape. And as you guys can see, it's being transformed into a 2 by 5 array. Now you guys, let's see what r1d looks like. That's our array we are working with. Let's see what the 2D array looks like. And as you guys can see, notice the square brackets. Forget the elements. The elements are not important. When it comes to understanding the logic behind the dimensions of an array, the only thing you want to focus on is the square brackets, okay? Notice, within the square brackets, we have a few values. That's fine. But this first square bracket here depicts or denotes one row in the array. The next array, or the next sub-array, this one here, is the second row in the array, which explains why in the shape we see 2 first. That's the number of rows, and therefore you guys understand how we are getting that 2. If you ask yourself, where's the 5 coming from? Logically speaking, picture this as a table. We've got 2 rows, the commas, the delimiters, hence we have 5 columns, which explains the 5 we see there. So that's that. I'm not touching on reshaping again. I hope you guys understand that. What I'd also like to, demonstrate to you guys, that is a possibility and kind of supported by NumPy. So let us work with this. Okay, I will create another example for you guys. We'll use a thousand element array once again. It's exactly the same. It's just another technique that can be utilized in order to create a reshaped array. So it's kind of like a inverted commas variant of the reshape function, yet it is still a reshape function. Okay, so let's view that. So r1d is equals to a range, so I'm just doing 1000 here, a 1000 element array in a one-dimensional representation. I'm taking that and I want to create a 3D array, numpy.reshape. Now this is something I should have discussed, and as I'm doing it now, so basically we have the ability to pass in a. As you can tell, guys, gives a shape. This is what the reshape function does, gives a shape, a new shape to an array without changing its data. That's why I told you number of elements before has to be number of equal to the number of elements after. And a is something that I'd like to talk about. It's just a parameter. It's array like. It's the array to be reshaped. This is not entirely important, but as I said, it's very good practice to know the parameters of the functions that you are working with. So I mean, if you look above, right, all we did was just pass the shape to the reshape function. In this case, we are doing the same, but we are passing in one more argument for a parameter. The parameter name is a, and yeah, new shape is the name of the next parameter. So new shape is equals to 10, 10, 10. Nothing different, guys. It's as we've seen in the previous example, which is right here. Okay, the only difference is I would just wanted to touch on these parameter names, you know, so it is interesting. I'd like to go ahead now. I'm printing shape and I want to print r3d.endem. We spoke about this in a previous lesson, right? I introduced you to it. I did not touch much on the endem method because at that stage we did not really know what dimensions are or what, you know, the levels of an array are. By levels I mean the levels of square brackets. What does each one represent? We know exactly now what each level of these square brackets mean. The first one is for the array itself, denotes the entire array. The first one is for the number of rows, and if there's a second one, there's a number of columns. So that's that. Anyway, one thing I'd like to speak now about is just a little bit more about the endem method. Endem is basically standing for number of dimensions. It will tell us the number of dimensions. Dimensions are basically, you know, your 1D, 2D, 3D, 4D, and so on, which can be deciphered from the number of square brackets you are working with. So I run this and I see I have a 10 by 10 by 10 telling me I am working with 3 dimensions. So that's that. I hope you guys find this interesting. The reshape method is really very interesting. So let's move on. Now I'd like to talk to you guys about another method that's provided by NumPy itself. This method is one that's used on an array, on an ND array. So I'll give you an example. Suppose we are working with a 3D array, okay? So, or let's do a 4D array. You know, we've already seen what a 3D array is, and in logic, if you see one 3D array, you've seen all 3D arrays that can exist, right? It's denoted by 3 pairs of square brackets. Now, we just, you know, tinkering around here, right, with a 4D array. So I'm going to do a numpy.zeros, make life easy for us. We just have to give it the shape. Let's do a 10 by 10 by 10 by 10, okay? And that in essence is giving us a 4D array. There's 4 levels of values provided, therefore telling us that there will be 4 dimensions, which is why we named it such. And my point is, if I print R4D, the array itself contains so many values that it's not able to display in full, you know, because of the fact that there are so many elements in this array. Now, the thing is, we can use another method. So in the event of us working with arrays such as these, right, arrays that have too many dimensions for us to actually, you know, utilize the array efficiently or effectively, or suppose we just needed to view a neater representation of the array, right? A fact is that an array with fewer dimensions will be much more neater to view at to the human eye. Okay, so what I mean is that, logically speaking, A 4 or 10 dimensional array would be much more busier to the human eye than a one dimensional array. And it is for these reasons that NumPy provides us with a method that is called revel. Okay, I just realized that I did not comment my code all along, but you guys can add comments here and there. So this revel, it's a method that is used on a NumPy array. Okay, so do we have a NumPy array here? Yes, we do. So I can say r1d is equals to r4d dot revel. And I would like to take some time to explain about this. So essentially the revel method does not take any compulsory parameters. All it does is return a flattened array. By flattened we mean a 1D array. Now as you can tell, I am calling the revel method on a NumPy array object, and this array object was initially 4D or 4 dimensions. Okay, array 1D, revel will always provide us with a one-dimensional array as output. Okay, so I'll give you a small demonstration. Print r4d.endem, and here I'm doing print r1d.endem. I'd also like to do, well, we can do it in the same spot, print r4d and print r1d. Now array 4D, array 1D. So first things first, I want you guys to view the dimension difference. Array 4D has 4 dimensions because, you know, we've created it like that. Array 1D, however, we did not create. Instead, array 1D is a new array that's created by reveling the 4-dimensional array. It basically flattened it, straightened everything out. So that is interesting. Now you guys saw what R4D looks like. It was so large, you know, we can't really see much. And now if I do array 1D, this is the array we see. So as you guys can tell, there is only one dimension. Look at the square brackets, guys. That's what the revel method did for us, as opposed to the array we started off with. So it is interesting. Now guys, I think, you know, with that we will end this video here. We had a good discussion about the concept of reshaping and reveling arrays using the NumPy package. So with that guys, thanks for your time, thanks for watching and staying till the end of the video. Do make sure to leave a like for this video if you have new takeaways of Python and NumPy especially. Subscribe to my channel, I will really appreciate that. Good luck with your work guys, and I will see you in the next YouTube video.